Good afternoon, everyone. Am I audible?
Yes, yes.
So, I'm Anureet, the host for today's event. So, before starting with the event, I would like to give you a brief introduction about ACM. As you all know, it is a global community for advancements in science and technology. It organizes various events and activities and has around 200 student chapters across different nations, of which CCET ACM is one of them. Over the years, CCET ACM Student Chapter has been growing and involving more tech enthusiasts who share their experiences and knowledge for their domain with other budding technocrats. Currently, we are working on research and development with a focus on web development, competitive programming, and designing. Our overall goal is to envision building a society of like minded people who love to code and have fun in a tech savvy environment. Keeping the same in mind, we have invited interested speakers to discuss and share their skills in the expertise with other individuals and technology associated people. Today's speakers are Inderpreet Singh and Rashandeep Singh from the Department of Computer Science and Engineering, Chandigarh College of Engineering and Technology. So, without taking much time, let's start the event. Deep dive into deep learning. The stage is all yours.
So, good afternoon, everyone. It's great to see you all, and thanks for coming here today. Today, I, Rashandeep Singh, and Inderpreet Singh are here to provide you some exciting information about new trending technology that is deep learning, which is, I believe, going to be very beneficial for you in future. We would like to thank ACM CCET for giving us this opportunity to conduct this event. Also, we would like to show our gratitude to our mentors Sunil sir and Sudhakar sir for this guidance.
Okay. Greetings, everyone. So, starting with the agenda. So, today we will be covering Introduction to Artificial Intelligence, a brief summary of machine learning, deep learning as a subset of artificial intelligence, few applications of deep learning. A brief mention would be there about the various different deep learning algorithms. Finally, we would be going through the problem statement for the today's experiment, in which we will be using artificial neural network, the basic one, for solving the problem. Now, to begin with, ANN is the base algorithm. So, ANN would be the best one for you to start deep learning. Finally, we will be going through the practical implementation on the collab environment.
So, since the invention of computers or machines, their capability to perform various tasks went on growing exponentially. Humans have developed the power of computer system in terms of their diverse working domains, their increasing speed, and reducing size with respect to time. A branch of computer science named artificial intelligence pursues creating computers or machines as intelligent as human beings. So now the main question arises that what is artificial intelligence or AI? According to father of artificial intelligence, it is the science and engineering of making intelligent machines, especially intelligent computer programs. So AI is a way of making a computer controlled robot, or a software think intelligently in the similar manner the intelligent human think. So AI is accomplished by studying how human brain thinks and how humans learn, they decide and work while trying to solve a problem, and then using the outcomes of the study as a basis of developing intelligent systems and software. So there are basically two goals of artificial intelligence. First is to create expert systems, that is the system which exhibit intelligent behavior, learn, demonstrate, explain, and advise its users. Second is to implement intelligent human intelligence in machines, creating systems that understand, think, learn, and behave like humans. So, artificial intelligence is widely used nowadays all over the applications. It has been dominant in various fields such as gaming, natural language processing, that is NLP, expert systems, vision systems, speech recognition, handwriting recognition, and intelligent robots. So, as seen in the diagram, artificial intelligence is a broader umbrella under which machine learning, that is ML, and deep learning, that is DL, comes. So, diagram here shows that ML is a subset of AI and DL is a subset of ML. So, AI means getting a computer to mimic human behavior in some way, as we have discussed in the earlier slide. Machine learning is a subset of AI and it consists of the techniques that enables computers to figure things out from the data and deliver AI applications. So before diving into deep learning, we should first know that what is machine learning or ML. So basically, ML is one of the most exciting technologies that one would have ever came across. It is evident from the name that it gives the computer that makes it most similar to humans, that is the ability to learn. Machine learning is actively being used today, perhaps in many more places than one would expect. One of the most well-known example is Facebook's news feed. The news feed uses machine learning to personalize each member's feed. If a member frequently stops or stops scrolling to read or like a particular friend's post, the news feed of the person will start to show more of the friend's activity earlier in the feed. So machine learning algorithms are often classified as supervised or unsupervised machine learning algorithms. Supervised machine learning algorithm can be applied what has been learned in the past to new data using labeled example to predict future events. Starting from the analysis of the known training dataset, the learning algorithm produces an inferred function to make predictions about the output values. It basically includes classification and regression problems, which we will be discussing in the further slides. On the other hand, unsupervised machine learning algorithms are when the information used to train is neither classified nor labeled. Unsupervised learning studies show how systems can infer a function to describe a hidden structure from unlabeled data. Clustering is a major algorithm or a problem that unsupervised machine learning uh, consists of. Deep learning, meanwhile, is a subset of machine learning that enables computer to solve more complex problems. So today our main focus is deep learning, and now Inderpreet will explain more about it.
Okay, so let's start with the main topic, that is deep learning. So as we discussed in the previous slide, deep learning is a subset of machine learning, which is a subset of AI. So basically, deep learning is based on neural networks, whose the main purpose is to mimic the human brain cells. In deep learning, we can say that nothing is programmed explicitly. So basically, deep learning, in short, can be considered as a class that makes use of numerous non-linear processing units so as to perform feature extraction as well as transformation. Now, deep learning models are capable enough to focus on accurate features of the dataset while only requiring a little guidance from the programmers, that is we. Now, deep learning algorithms are especially used, or we can say majorly used, in the places where large data set is there, that is number of inputs is enormous. And as we discussed, deep learning are implemented with the help of neural networks. And the idea behind the neural networks, or the inspiration, is the biological neurons, which is nothing but the brain cell of a human brain. Now, let's talk about, before diving into the technical stuff, let's talk about little applications of deep learning. Now, few years ago, you would have never imagined about self-driving cars, or even the Google Assistant, Alexa, which are the virtual assistant ones. But now you can see these are the everyday part of our life, and self-driving cars are almost there on the rim. Now, so these are only possible due to deep learning. As deep learning continues to fascinate us with endless possibilities, such as fraud detection, pixel detection, gaming, visual recognition, etc. So now, in this particular few slides, we would discuss few of the very important applications of deep learning, in which there's a lot of work has been done and also need to be done more. So starting with the self-driving cars. Now, deep learning is the only major focus which had bring these autonomous driving cars into life. Now, in these, through deep learning, we fed a million set of data to the models which train based on the deep learning algorithms, and then these are tested on the environment. One of the greatest powers in driving cars is the Uber, and the Uber artificial intelligence labs, which are situated at Pittsburgh, is not only working on making driverless cars but also trying to automate several features like smart food delivery features, automated driving. So here we can see that Uber is not only aiming to get a driverless car but also aiming to automate each and every aspect of their machinery through deep learning. Next, we are going to talk about natural language processing. So, as we all know, that understanding a language is very difficult for us. But since we, by birth, we have a constant exposure of different social settings, and we are getting trained in a particular language, humans help to develop appropriate responses and a personalized form for every scenario. Now, this particular phrase is what deep learning is trying to imitate through the training of the machines to catch the linguistic nuances and frame appropriate responses. Now, you all have known about the document summarization, which is being widely used and tested in legal sphere, making the paralegals, the old ones, completely obsolete. Other things which you have mostly visited on the online websites, such as answering questions, language modeling, classifying text, Twitter analysis, which is one of the most famous problems, are which are being used at a very broad level, are one of the basic subsets of machine learning of the NLP. Now, also before deep learning, NLP was still there in picture, but it was used through the logistic regression and the SVMs, that is state vector machines, from the machine learning. But these were highly time consuming and memory consuming, which were not really working at a real time scenarios. But with the help of deep learning based CNNs, that is convolution neural networks, reinforcement learning, RNNs, etc., now NLP is gaining maturity more than ever. Okay. So this one, the visual recognition is one of the most famous problems, and most people, after a certain level of understanding with deep learning, try to go through these problems. So I would just take an example of a special case of visual recognition. So imagine you are going through the old photographs you have taken in your gallery, or let's say your Google Drive, and you decide to get few of them extracted or framed or anything else you want to do with particular photo. But putting the manual, you need to put in manual effort to accomplish this task, as you need to understand the metadata behind them and take out each and specific image, which is very time consuming. Now, in this respect, deep learning comes, as deep learning can not only review the metadata, but they are also capable of taking out the location images based on the location detected in the background. Whereas in the earlier parts, the max you could do was filter out the images based on dates. But nowadays, the downloaded images doesn't even contain the date metadata.
So another domain benefiting from deep learning is banking and financial sector. That is placed with the task of fraud detection with money transactions going digital. Autoencoders in Keras and TensorFlow, that are the famous libraries of Python language, are being developed to detect credit card frauds, saving $1 billion of cost in recovery and insurance for financial institutes. Fraud prevention and detection are done based on identifying patterns in customer transaction and credit scores, identifying anomalous behavior and outliers. Classification and regression machine learning techniques that we will be focusing in further slides, and neural networks are used for fraud detection. While machine learning is mostly used for highlighting the case for fraud requiring human deliberation, deep learning is trying to minimize these efforts by scaling efforts. So now deep learning is also used in entertainment industry. For example, in Wimbledon 2018, it used IBM Watson to analyze players' emotions and expression through hundreds of hours of footage to auto-generate highlights for telecast. This saved them a lot of effort and cost. Thanks to deep learning that they were able to factor in audience response and match or player popularity to come up with more accurate model. Otherwise, it would have the highlights of more expressive or aggressive players. Netflix and Amazon are enhancing their deep learning capabilities to provide a personalized experience to its viewers by creating their personas, factoring in show preferences, time of access, history, etc., to recommend shows that are of liking in a particular viewer. Deep learning video analysis can help to save hours of manual effort for audio video sync and its testing, transcripts, and tagging. Content editing and auto content creations are now a reality thanks to deep learning again, and it contributes to face and pattern recognition. Deep learning AI is revolutionizing the filmmaking process as cameras learn to study human body language to imbibe its virtual characters. Other deep learning applications include news aggregation, fraud detection, healthcare detecting developmental delay in children, colorization of black and white images, automatic handwriting generation, automatic game playing, and virtual assistants. So, coming to the algorithms of deep learning, the table given below is able to majorly cover all the important deep learning algorithms. They are basically divided into two sections. First is the supervised and unsupervised learning. We have discussed what is unsupervised and supervised in the machine learning section. So, starting with the supervised learning, it consists of three algorithms. First one is the artificial neural network. It is the most basic algorithm, that is ANN, of deep learning, and is used for simple regression and classification problems. A regression problem is when the output is real or a continuous value such as salary or weight. We can have salary such as 10,000, 10,200, 50,000, 1 lakh, or any continuous real number. So if we have to predict a continuous real number, it is one of the regression problem. On the other hand, classification problem is the output variable, is when the output variable is a category such as red or blue, a disease or no disease, true or false, yes or no, or 0 or 1. So next one is the convolution neural network, that is CNN. They are usually used for image classification or video classification that are in the domain of computer vision. They are one of the leading algorithms in the field where which researchers use nowadays. The final supervised deep learning algorithm is recurrent neural network. It is used in time series analysis. We would try to explain CNN and RNN, that is convolution neural network and recurrent neural network, in the further upcoming events which we would host. But today the focus will be on the basic ANN algorithm to begin with the deep learning part. So the other three deep learning algorithms are self-organizing maps, deep Boltzmann's machine autoencoders that are used for complex unsupervised problem. They have great industrial importance.
Okay, so let's start with ANNs. So now, neural networks can be considered basically as a set of algorithms which are inspired by the functioning of the human brain. So consider that when generally you open your eyes, what you see is called the data, and it is processed by the neurons. And in this case, the neurons are called data processing cells. And in your brain, which recognizes what is around you. A basic neural network, that is the artificial neural network ANN, are composed of multiple nodes which try to imitate the same process which is done by the biological neurons of the human brain. These neurons are connected by links and they interact with one another. Now, nodes can take input file and perform simple operation on the information through those files. And the result of these nodes is in the form of the output. Now, the term ANN, as we know, is derived from the biological neurons which are developed at human brain. And since since the human brain is also interconnected, each neuron is interconnected. So, on the similar basis, the neurons in an ANN is all also interconnected to one another at various layers. These layers would be explained in the later section of the PPT. No, and also in technical term, these neurons are known as nodes. The given figure, as you can see, demonstrates a particular biological neuron. Now, in this you can see the dendrites, which represents the input in a biological sphere, and cell nuclei is the basic node which we are talking about, whereas the synapses represents the weights, and finally the axon represents the output. Okay. So now this is a technical demonstrated figure of what one neuron in an ANN is. So as you can see, as you all know that in AI, we attempt to mimic the network of neurons made up of human brain, and so the computer will have an option to understand things and make decisions based on the human like behavior. Since we all know that the main purpose of the very start of AI was to make something like human, so it is the most nearest thing to achieving such tasks. And also these neural networks are designed programmably, and on a technical aspect they are simply like interconnected brain cells. Okay. So next we will talk about the associated weights, and what is B and what is F. So W is basically given a weight to a particular input. As you can see here, it is given based on the importance of each input. So different inputs have different importance. So will their weights differ, and bias is added for a particular reason which we will explain earlier. Finally, this F defines the activation function, which we will be explaining in the next slide. And if we sum up the after summation of all weighted inputs plus the bias and applying the activation function on them, the resultant is the output from one node. And there are large number of nodes based on the model transformation. So let's talk about the activation functions. Now in the previous slide where you saw the y, that is f of w summation of wx plus b, gives the diagram of a single neuron. The function f is basically a non-linear function and known as activation function. The purpose of activation function to implement here was to add a non-linearity to the output of the neurons. Now see, now in most of the real world data, when you get about, let's say, house prediction or some disease detection, any classification problems, the real world data is always mostly non-linear, and we want to learn have the neurons to learn the similar representation of non-linearity. Since every activation function takes a single number and performs certain mathematical operation to provide these nonlinearity. As you can see in these graphs, these are the few very important activation functions that are majorly used in each and every problem. So starting with the sigmoid, what it does is basically it takes a single real world value and squashes it between 0 and 1. That is, keep the values either 0 or 1. Now, talking about tan h takes real world values and squashes it between the range of -1 to 1. Similarly, ReLU, which stands for rectified linear unit, it takes the real world value and thresholds it at 0, which means that the negative values are become 0, whereas the positive remains the positive one. Also, through experimental processes and various research papers, has been found that ReLUs work very well within the hidden layers. The layers would be explained in the next section. On a basic form, the middle layers, which do the main computation, and whereas the sigmoid function is one of the best functions used for the binary classifications or any other classification mechanisms. Okay. So now let's talk about the layers. So this is a very basic structure of what an ANN looks like. So the green nodes represents the input, and input is basically the raw information which is fed into our neural network. So thus the name very well suggests that input layer. The green circles here is the input layer. Next one is the hidden layer. Now hidden layers are the most important one, as these are the basic nodes which perform the non-linearity or apply any function to our input to get us the desired output. So it is basically determined by the activity of the input units as well as the weights which we insert between the input unit as well as the hidden layers. Finally, we get the output layer, that is the red one. So here the architecture is of a classification problem, of a binary classification problem. So output would be either yes or no. So this output depends on the summation of all the activities from the hidden layer plus their weight and multiplied by their weights. So the resultant would be based on the hidden layers, which would be shown in the output layers. Okay, so this was the basic architecture of a neural network. So how this neural network works is it is based on the two parts, that is feed forward propagation and backward propagation. Now, starting with the feed forward propagation. So the in this forward propagation, the input data is fed in the forward direction from as you can see in the figure that x1, x2, x3 is the input data. Now each hidden layer accepts the input data and processes it as per the activation functions and the weights, and then passes it to the successive layer, which can be the output layer or hidden layer. In this case, we have three hidden layers. Okay. Also, one thing to be noted, when we are developing a manual network, the data should not flow backwards. So, if the data flows backward, then it would result in a cycle, and an output would be never generated. Okay. So here you can see from the image also that after an output red circle is there, that is an output is given, it is compared with the already results we have, and based on the difference between those, an error is calculated. So this error is very important in the next section. Okay. So next one is the backward propagation. Now backward propagation is the basic essence of neural network training. What is deep learning is only derived through this backward propagation. Now its basic purpose is to fine tune the weights in the neural network based on the error we found out in the previous section. So the error was the y true minus y prediction, that is the true value of y minus the predicted value through our model, and based on the error the weights are increased or decreased, making the making it reliable for and more better, the less the error, the better is the training and better is the model generalization. Backward propagation of errors is the longer term for the back propagation. Now, it is the standard method of training neural networks. Now, this method also helps to calculate the gradient of a loss function, which we will discuss in the training section. Okay. So, as you can even see in the diagram, also this GIF, how it is working, error is coming, and based on the error, the weights are changed. Okay. So, here you can see it's a full structure of an artificial neural network. So now this can be in a very computer science manner. It can be said as a weighted directed graph where the neurons act as the graph nodes, and the association between neuron outputs and neuron inputs can be viewed as a directed edges and with weights. The ANN receives the input signal from the external source, as we can see here x1, x2, and so on, and it is in the form of a pattern for an image, or in a form of vector for images. Now these inputs are then further mathematically assigned the notation of xn for every n number of inputs. Now, after each input is multiplied by its corresponding weights, as we have discussed earlier, and in general terms, these weights normally represent the strength of the interconnection between neurons inside the ANN, which we discussed was that basically it shows the importance of each and every connection. And all this is done inside the node, that is the weighted inputs are summarized inside the computing unit. Also, now if these weighted units are zero, then results are not possible. Thus, to make the outputs non-zero or an something which is conventional, if so, for example, the results are unconventional and we need to get the some better results, then we need to add some bias into it. Here, the application of bias comes. Now bias has the same input and weights equal to 1. Here the total of weighted inputs can be ranged between 0 to positive infinity.
Okay, so after diving into what ANN is, the problem statement which we will be using today is to predict heart disease using ANN. With today's modern lifestyle, the large population of world are getting diagnosed with heart diseases. It is becoming one of the topmost reasons for loss of life, as the death rate is ever increasing as a result of contrary heart disease. The people working closely with the heart care depend largely on the patient's data to predict heart and may that the patient may have heavy risk of heart disease due to several underlying risk factors such as diabetes, high blood pressure, high cholesterol, abnormal pulse rate, and many other factors. It makes very difficult for prediction of heart diseases. So various methods in the data mining and neural networks have been implemented to explore the austerity of heart disease like ANN, which we will be using today. So in this model, we are going to develop an efficient prediction model for heart disease using neural network. So this slide shows the snap of the CSV file, that is the dataset file. In the dataset, we have 13 columns in which we are given different attributes such as sex, age, cholesterol level, etc. And we are given a target column which tells us whether the person has heart disease or not. We will keep all the columns as independent variables other than the target column because it will be our dependent variable. We will build an ANN which will predict whether a person has a heart disease or not given other attributes of the person. So as we can see the snap, the first 13 columns from age till THAL are the independent variables, and these independent variables will be used to predict the outcome, that is the target value, where 1 signifies that person has the heart disease and 0 signifies the person doesn't have the heart disease. So now we will see the implementation of ANN in Python. So basically, the first step is the data pre-processing, which includes importing the libraries. We have basically imported two libraries. First is the NumPy. NumPy is the Python library used for working with arrays. It also has functions for working in domains of linear algebra, Fourier transformation, and matrices. And the second library which we are importing is Pandas. Pandas is a Python library which is used to analyze data. It is basically used to import the dataset in a Python operational form. Now, once the libraries are imported, and now we will import the dataset using the pandas library. The function used in this would be read underscore CSV. This is an inbuilt function of the pandas library. Now the dataset will be divided into the input section, that is X, and the output section using the ilog function. So here the uh, ilog, in the bracket of ilog, the first semicolon before the comma represents that we will be selecting all the rows, and the second after the comma, the colon followed by -1 tells that uh, we will be selecting all the columns except the last one, and it will be stored in the X variable, that is all the independent columns will be stored in the X variable, and the output, that is the target, will be stored in Y. And here -1 after the comma represents that it will be storing only the target value, that is the last column. So after importing the dataset, we will split the data into training and test sets. In this proposed methodology, the dataset is used to train the ANN to predict the heart disease. The dataset is further divided into test and train sets in the ratio 80:20. So here test size equal to zero point 0.2 represents that we will be having 20% of the dataset as the test dataset. The 20% of testing set will not be involved in training of the models, but it will be used to validate the test results of the ANN models. So after training and splitting the data set into training and test sets, feature scaling is done. Feature scaling is used to provide acquire superior outcomes through the models. Feature scaling is performed to reform the data points in a certain range, that is to normalize the data points. Such process helps to accelerate the calculations in the algorithms as well as helps to increase the accuracy. In this experiment, standard scalar transformation of the data set is done. There are other standards, there are other feature scaling options, but it has been observed that standard scalar is the best suited for classification problems. So standard scalar is used to achieve standardization, which is performed by subtraction of the average of all the data by attributes. That is the data of all of one column. All the data of one column will be averaged, and it will be subtracted and further divided by the standard deviation.
Okay. So now let's start with the model building. So basically, this is the code shown on this slide is the major code which would be used for model. Now this is majorly known as the artificial neural network. Now, for the particular problem statement, we will be using Keras. And I would even suggest if you are even a beginner, start with Keras and then go backward towards the mathematical stuff. As Keras is one of the most easiest stuff and a wrapper on TensorFlow, and it is very, very easy for it for applying the deep learning knowledge in the form of Keras. And technically, on a just technical knowledge aspect, Keras is an open source software which is provided which has provided a Python interface for various models. Like we can perform each and every model just with a few lines of code in Keras. And for the particular problem, we would be using the sequential model as it is the most appropriate one for a plain stack of layers where each layer has exactly one input tensor and one output tensor. So sequential model will be the perfect fit for the particular classification problem. So also, as you can see here that the dense layers are there. So basically this dense layer is means that neural network is connected deeply, which means that each neuron in the dense layer receives input from all the neurons in the previous cell. So as we can see, there are six neurons. So basically all the six neurons in the first layer, and consider first neuron from the second layer, all the six neurons give some input to this neuron, thus making it deeply connected one. That's why the name dense layer is given here. And even dense layer, which overall in a form of groups are known as fully connected network, is the most commonly used models in deep learning. This dense layer or the fully connected group is used in almost each and every aspect for like RNNs or convolutions for the final results. Okay. So now, in as you can see in this, that we have two hidden layers and a one output layer. So and input is already in the form of data. So if on a very technical, on a very architectural aspect, the data set is considered the first input layer. Then we have two hidden layers with the units equal to six. Units here represents the nodes, and finally we have a final sigmoid based output, that is the binary output of 0 or 1, which says either we have a heart disease or no, we don't have a heart disease. Okay. So here you can see that there are kernel initializers. So basically kernel initializers, what they do is that they initialize the weights, since like we have to train the model. So for the very first iteration of all the neuron of all the input data through the nodes, we need to give some random weights, or it can be even zero. But mathematically and even experimentally it has been proved that giving zero weight is not good, and even giving a constant value, like if we given 5 to each and every weight, even that is also not good for better model generalization. So random initialization is the best one. So in this model there is a uniform random initialization, and initializers define the way that initial random weights, initial ones, after the first iteration, the weights are changed automatically based on the error which we have got through the back propagation. Okay, so and nextly we can see that activation function is used relu in both the hidden layers. Activation function has been used is relu, so it will provide the necessary non-linearity to our model. And next we can see that only in the first hidden layer input dimension is given to be 13. So it is one of the very good properties of keras that the initial input dimension, that is 13 columns, we have to give. After that, the next output dimensions are automatically calculated by the keras, and they are automatically inputted to the next classifier. So we don't need to add any extra input dimension for the following layers, as it is automated calculation is possible. Finally, we can see that dense layer of unit 1 is there with an activation function of sigmoid, which would give us the output results. So this is a very small model, but even this model can give a decent results. We will see in the experimental process. Okay. So the previous slide showed us the model architecture. So in the previous slides aspect, we can see that now we have the graph, but now we need to have the training of this graph. So here comes the classifiers, two functions, compile and fit. Initially, the compile we will basically form all the aspects of loss, how we'll calculate the loss, how we'll calculate the gradient, what will be the metric, and starting with the optimizer. So I will just start with the loss function, as then optimizer would make a little more sense. So the loss function is one of the important components of neural networks. Loss is nothing but the prediction error of neural network, as discussed, and the method to calculate the loss is called the loss function. In simple words, loss is used to calculate the gradients, and these gradients are then used for updating the weights of our neural architecture or neural network. So this is basically how neural network is trained. Keras has a lot of inbuilt functions for different inbuilt loss functions for various tasks or various models. So I will just name a few. For example, mean squared error (MSE), binary cross entropy (BCE), categorical cross entropy (CC), sparse categorical cross entropy. But for the major purpose, and even when you start to learn about deep learning, binary cross entropies or the cross entropy ones would be the most usable forms. Okay, so talking about this binary cross entropy, it is used for mostly for the binary classification task, and in this you just need to have one output node, and that means that there should be only two classes, and the output should pass through the sigmoid function, as it brings the resultant into 0 and 1 form. Okay, so loss basically tells that how poorly or how good the model is performing at the particular instant. So now we need to we need this loss to train further our model such that it performs better than the earlier iteration. Essentially, what we need to do is to take the loss and try to minimize it, because the lower the loss, the better the model, the better is the generalization of the model. And this process of minimizing or even sometimes maximizing based on the problem statement uh, of the loss function, this process is called as optimization. So here the optimizers will just make a little more sense. So optimizers are the algorithms or the methods that are used to change the attributes of the neural network, which are weights or even the learning rate, and to reduce the loss or even maximize it. Optimizers are used to solve optimization problems by minimizing this loss function. There are various other types of loss function, but that is not in the scope of our today's lecture. So now training the model is training of this model has been done through the Adams optimizer, Adam is considered as one of the first order gradient based optimization of stochastic objective functions centered on the adaptive assessment of lower order movements. So this was a little more technical, but on a basic level, what benefits from the Adam is that it is computationally very efficient, and the memory requirement of Adam optimizer is very less. So also, it is considered to be invariant to the diagonal rescaling of the gradients, and as well fit for challenges that are substantial in terms of parameter or data. So basically, even there, if there is a little deviation in the input data, the model that Adams would be still able to incorporate those changes. So finally, we would use the fit function that we will be using for the training of our model. Okay. So now, in terms of artificial neural networks, or even in terms of deep learning, what an epoch refers is to one cycle through the full training data set. Now, usually, training a neural network takes more than a few epochs. And in other words, if we feed a neural network the training data for more than one epoch in different patterns, so consider that if we have range of input from 1 to 100, so first in orderly fashion we have inputted, then some like 50 started, so randomly the input data set is provided in each epoch. It is an automated function through the keras only, and which is a very good one, uh, as it in this we can hope that with the changes there would be a very efficient and a generalized model available. Okay. And also, just to clarify, an epoch is often mixed up with an iteration. So, iteration is the number of batches or steps through partition package. So, here the batch size or the batch is the partition package for this model. So, consider that if we have in total 100 100 elements in a training set, 100 rows in a training set, so and a batch size is of 10. So first the first 10 will be trained on the model in the first epoch. So this is one iteration, then the next 10, then the next in the next iteration. So in one epoch, in this particular case, there will be 10 iterations. And so consider if we have three epochs, so there will be in total 30 iteration on a batch size of 10. So there is a slight variation between iteration and an epoch. And so it is mostly even confused because sometimes the batch size is equal to the training set only. So in that case, the iteration number of iteration as well as number of epochs tends to become the same one. Okay. So now after this particular classifier.fit, our model is ready. Now we just need to evaluate it and get the accuracies. Okay. So after the model is ready, we need to predict it, or we need to make the prediction or evaluate the model based on the training. So here you can see that that y predict equals to classifier dot predict. Classifier is the model that is formed. So classifier can be considered as an object if so based on object oriented programming, if you have a little bit knowledge about that. So it is the classifier is the basic object formed by the keras to be used as a model. So this classifier will be predicting on the test data set, which we have already taken out from the training data set apart, so that it remains unseen, and a true results can be considered out of from this. And next you can see is that y predict greater than zero point 0.5. So basically, as we know that sigmoid gives the result between 0 and 1. So anything above zero point 0.5 would be considered as 1, and anything less than zero point 0.5 would be considered as 0. So this means that above zero point 0.1 the heart disease is there, and less than zero point 0.5 there will be no heart disease. So thus we have formed a binary classifier here. Finally, we have got our predicted values on the test data, and we already have a true values on the test data also. So we just need to evaluate them. So here comes the role of a confusion matrix. This is one of the best form to evaluate the model, not on the accuracy aspect, but also on the aspect that where our model is wrong. So you can see that true positive, here we have four things: true positive, false negative, false positive, true negative. Okay, so true positive means, that is TP, it means that the R classifier or a R architecture model has given the result true, and the true result is also, and the already predicted, already given result in the data set is also true. So in this case, R classifier was formed good. Next is the consider is the true negative. Now true negative means that R classifier has given the result negative as well as the real result is also negative. And on the contrary, false negative means that R classifier have given the result positive. That is, R classifier has given that there is a heart disease, but on the real scenario or on the given data set, there is no heart disease. That is, the result in the real value is false. And the finally the false positive ones is that our classifier has given the result positive, that is there is a heart disease. Sorry, our classifier has given the result that is there is no heart disease, but in actual there is a heart disease. So the false positive ones are the most dangerous ones, and we need to give a special attention on them, as just in this example only. So consider that in a doctor application we have employed this, and it says that there is no heart disease, and but in reality there was one. So in this case, the consequences can be very severe. So overall, the good things in this model is the true positive and the true negative, whereas the false positive and the false negative are the bad ones. We take out the accuracy of the model based on true positive plus true negative upon the summation of all the four. Okay, so now we will go through the little technical aspect. Thank you from the PPT size. Now we will go through the collab environment.
I hope my screen is visible.
Yes.
Okay, so this is the collab environment. We will go through the implementation in it and give a recap of what the implementation is. How does it actually work? You just have to simply write Google Colab in Google and create a new notebook here. So first one is to upload the file in Colab environment, that is the database which we have in our local computer. We have to upload it in a Colab environment to make run the various things that to predict the accuracy. So you can just go on here and you have to type that we have to import data from the local computer. So this is what here they are. Collab is already giving us the code, so you have to just copy paste and uh, paste it here, and you have to choose file from your local computer, that is the hard CSV file I am having in my local computer, and this way the file will be uploaded. So after that you have to import the libraries and then import the dataset using a read CSV, and dataset.head will be able to show the first five rows of the dataset along with its column. So after that, we will be splitting the data in
Rashan, just zoom it a little.
yes. So after importing the data, we will divide the data into input. That is, all the input will be stored in X, and all the target variable will be stored in Y. So this is what the X looks like, and this is the Y what uh, we have stored it in a Y. After storing, we will split the dataset into training and test, which we will be importing from the sklearn library. So we will be storing 80% of the data in training and 20% of the data in the test size. After splitting, we will be performing feature scaling using standard scaler, which will be again importing from sklearn. So after standard scaling, then importing the Keras library and its packages for initializing the ANN, which is initialized here. Uh, that is, classifier is equal to sequential. Classifier will be now made as an object. So classifier will call the class of add with the activation function as relu, and units will be equal to 6 and input dimension will be equal to 13 as discussed by Inderpreet in the PPT. After this, we will be adding the second hidden layer and then finally the output layer using the activation function as sigmoid, and output will be just a one circle, like as shown in the network of ANN. There will be just a one circle or the one unit giving that yes, the person has a heart disease or not. So finally, we will compile the ANN, that is classifier.compile, using the Adam optimizer and binary cross entropy loss function. So this is the basically summary of the classifier. This first predicts the first hidden layer, this is the second hidden layer, and this is the output layer. So after the compilation is done, then here comes the fitting of ANN using the epochs, and the batch size is equal to 10. This is basically used to get the actual model of ANN which we will be making. So this will take some time depending on the entries that you have in the database. For example, in this hard data set, there are 300 around 400 data entries, so it will take around 3 to 4 seconds, but in the real world scenarios there are large number of entries in thousands, so it will take time depending on the size of data set. Finally, there will be prediction, and if y predict is greater than zero point 0.5, it will be equal to 1, and otherwise it will be equal to 0, and we will be storing it in y predict. Finally, we will be making the confusion matrix, and we will be importing this from sklearn. And this is what the confusion matrix looks like, which means that 22 means the 22 data entries is predicted true, and it is actually true in the test dataset, and 30 is predicted false, and it's actually false in the dataset. This 5 and 4 means that we are getting the wrong results as the true test dataset. So, seeing this, we will be calculating the accuracy, and it comes out to be 85 and close to 86%, which means that 86% of that model is predicting 86% correct values. So, this was it from our side about the ANN. And now there is a task for you all for the certification of this event, which Inder will explain more about it.
Oh, okay. So thank you all for being with us, and so I hope you like the event. So basically, we tried to give a very brief summary about ANN so that there is enough for you to go through and go in detail. So talking about this certification aspect, the basic task would be to get on the GitHub, and we will provide you just the links and fork this repository, and then input this into the event submission, and put your collab file, or you can just go on collab, or for those who know about Jupyter, can form this similar type of notebook. We have provided you two data sets. One is the hard data set only, and other is the churn data set. So you have to do the binary classification through ANN, or if you have any further knowledge, or you want to try something else, we are open to it, and you can just go through it and give. You can have even more than one submissions. And we have also made this at Hacktober's accepted repository, so you would just get the even the Hacktober PRs. So if you want multiple PRs, that would be also possible. So, but just an important thing that you should have your name and email ID in the first cell of your notebook, as well as you need to have name and email ID saved on the PDF file that you would be uploading. Also, I know that it can be a little bit tough or for the beginners, and so we would even provide you with the collab links. We would update it here only, and you can just even make changes, try your new stuffs. Like we have considered 6 units, you can have 10 units. What would be their inaccuracy? So like we had a good accuracy of 85% even with these 6 units, and so you can have more number of layers, and you can see there are problems. You can visit the keras.io. It is a great open source platform, and each and every code which we have written, or you will even write, each and everything is in detailed explained there and given there. So the community is very strong. The documentation of keras is very strong for the beginners. Even also there is a special tutorial that would walk through, And in the notebook also we would try to add a little more description about the functions so you can easily use them. And also we have provided you with the ppt for more understanding. So the timing for this task submission would be till tomorrow night. I would suggest you to try to submit it as earlier as possible. I think it won't take more than 15 to 20 minutes, and the certification would be provided you through the CCT ACM at max in a week or two. And that's it from our side. We are open to questions.
And I have provided link of GitHub here in the chat, and you can
Good,
also
good
type
afternoon, sir.
my name there if you are not able to
So first
get
of
into the link. Yes, sir. Good
all, a
afternoon.
very good afternoon, everyone, and I'm thankful. I'm thankful to both the speakers, Inder and Rashan, and I have listened all the lectures, the whole lectures, and it is completely full of insight of each and everything from the basics to the advanced, and very wonderful sessions given by you both, Inder and Rashandeep. So,
Thank you.
heartiest congratulations for this wonderful and full of insight knowledge about the ANN, and now the practically you demonstrated and taken each and every small things fundamentally very wonderful and very well coordinated and well explained. So I'm so much excited.
Thank you, sir.
Thank
That's
you.
that's great and awesome, and wish you all the best for your futures and this learning.
Thank you, sir.
Thank you.
Great. Please continue. Please continue.
Okay, so I have provided the link of GitHub, and the deadline is tomorrow night. If not the link, you can just type Rashandeep on GitHub and go to the repo that is deep diving into deep learning. And there will be a folder called event submission. You have to just upload with the file name as your name and your email ID. So that's all from our side.
You
Any
can even
questions?
message us or have raise the issue, and we will be continuously monitoring the repo, so that if you have any doubts or you need any support, we will be always there. Yeah, Anvit, you can start.
So if you still have any doubt, you can ask them.
Where we have to submit the notebook file.
So you have to basically fork the GitHub repo of the link provided in the chat section, and you have to upload it in the event section of that repo.
There will be a drop down with a like label called add file. You have to just drag and drop your file there, and it will give us the request, and we will accept it, and you will be done with it.
Yeah. It would also help you in the Hacktober event, and you all know as Hacktober event is going, I would encourage all of you to make 4 PRs on the GitHub, as nothing, it would just give you a shirt. Yeah, we would be here for 5 more minutes, and if anyone wants to ask anything, we are here. Otherwise, I think that's it from the event. Anvit?
So thank you so much, Inderpreet and Rashandeep, for such an informative and interesting event. I'm sure all the attendees must have got the insights into deep learning. You'll be provided with the recording till today evening, and you can also check our YouTube channel and other social media links which we are providing in the chat box for further updates of the events and all of the previous events and that we have done. So the links of the social media would be shared in the chat box.